In this video, let us solve problems based on tangents to circles. So we've got a problem here which reads like this. Two circles with centers A and B of radii 3 centimeters and 4 centimeters respectively intersect at 2 points C and D such that AC and BC are tangents to the two circles. Find the length of the common chord CD. Now, what does it mean? It says that the radius of this circle is a tangent to this circle and the radius of this circle is a tangent to this circle. And the most important thing is we've got a common chord which is CD. That means it is a chord for both the circles. That's what it means. So now what is the question? We need to find the length of this chord which is the same for both the circles, which is common for both the circles. So what we have to do as far as this question is concerned is find the length of CD. So let's see how do we go about doing that. Now since tangent at a point to a circle is perpendicular to the radius through the point of contact, we've got angle ACB as 90 degrees because you can see that either you consider AC as the radius and BC as a tangent. BC will be a tangent to this circle and therefore it will form a right angle with this radius. Or if you consider AC as the tangent and BC as the radius, again this tangent is going to form a 90 degrees with that radius to the point of contact. So therefore we've got angle ACB equal to 90 degrees, a right angle. So now let us consider the triangle ACB. Now since we've established this is a right angle, let us take that triangle which contains a right angle and that becomes a right angle triangle. So in the triangle ACB, we've got the side opposite to the right angle is AB. So we've got AB as a hypotenuse. So AB square equals the hypotenuse square equals the sum of the square of the other two sides. So AB square equals AC square plus BC square. So we've got AB square equals, we've got AC as 3. So AC square is 3 square. We've got BC as 4, so BC square is 4 square. So we've got AB square is 3 square is 9 plus 4 square is 16. So AB square is 9 plus 16 is 25. So if AB square is 25, AB is square root of 25. So we've got AB equal to 5 centimeters. So we've found the length of AB. That's fine, but what we have to find is the length of CD, which is the common chord to both the circles. So that's what we have to find. So we found AB as equal to 5 centimeters. Now, how are we going to find the length of CD? Well, now since the line joining the centers of the two intersecting circles is perpendicular bisector of their chord, we can clearly see that it is a perpendicular bisector of the chord CD. So therefore, we've got AP as perpendicular to CD, and we've got CP equals PD because AB is the perpendicular bisector of CD. So we've got CP equal to PD or DP. So now let AP be X. Let AP be equal to X centimeters. Then we'll have BP is equal to 5 minus X. Right? Because we found AB to be equal to 5 centimeters. So therefore we've got BP equals 5 minus X. And further let CP equal to DP be Y centimeters. We've already established that CP equals to PD and let that be equal to Y centimeters. Let CP equal to PD equal to Y centimeters. Now in triangles APC, let me use this color. In triangle APC, now we have to find the length of CD, right? So the reason we found out, we're trying to find out AP is once you have this triangle ACP, you've got AP and AC, we can easily find the length of CP using the Pythagoras theorem because we've already established that AB is a perpendicular bisector of PED and this will be a right angle. So once you find that, you can easily find the length of CD. So that is the whole logic behind these steps. So we've got CP equal to PD equal to Y centimeters. Now in triangle APC and BPC, let us apply the Pythagoras theorem that we have. So therefore, by applying the Pythagoras theorem for the triangles APC and BPC, we get AC square equals AP square plus CP square. And similarly for the triangle BPC, we will have CB square because it's opposite to the right angle here. So CB square equals CP square plus PB square, right? So now we've got AC as 3. So let's write it 3 square. We need to find AP square. So we've got AP as x. So let's take this as x square, and CP is y. So let's take it as y square. And CB is 4 centimeters. So CB square is 4 square. And then we've got CP as y again. So plus PB is CP is y, then CP square is y square, and then we've got PB or BP. PB is all the same. So we've got PB as 5 minus x the whole square. So we've got these two equations here. Now let us subtract this equation from this. So we are subtracting 3 square equals x square plus y square from 4 square equals y square plus 5 minus x the whole square. In that case, we get 4 square minus 3 square equal to y square plus 5 minus x the whole square minus x square minus of x square plus y square, right? This is what we've got. So now, after we've got this, we've got 16. 4 square is 16 and 3 square is 9. So 16 minus 9, we get 7 equals now y square. Y square is going to get cancelled. And we're going to have what is left is 5 minus x the whole square is nothing but 5 square plus x square minus 10x. Use a minus b the whole square and then minus x square. X square is going to get cancelled. So all we are going to have left is 7 equals 5 square is 25. So 7 equals 25 minus 10x, which is nothing but 10x equals 25 minus 7. So 10x equals 25 minus 7 is 18. So we have x equals 18 by 10, or x equals 1.8 centimeters. So we found the value of x. So x is nothing but AP. So now we found AP to be 1.8. So now, considering this right angle, we've got two datas. All we have to find is CP, which is again very simple. Let me use this space for that. So considering triangle APC, let us apply the Pythagoras theorem. We'll get AC square equals AP square plus CP square. We've got AP and AC, we just have to find CP. So 3 square equals 1.8 square plus CP square. We've got CP square equals 3 square minus 1.8 square. So we have CP equal to root of 9 minus 1.8 square. Right? So we've got it. You just have to work it out. And then eventually we need some space. So let me use this space here. So we have CP equals root of 5.76. So CP equals square root of 5.76 is 2.4 centimeters. So we found CP to be equal to 2.4 centimeters. So we have to find CD. So since CP equals PD, if CP is 2.4, PD is also 2.4. So 2.4 plus 2.4 is nothing but 4.8 centimeters. So therefore, CD equal to 4.8 centimeter. That's what we had to find. All right. So it did turn out to be a pretty lengthy problem. But let me summarize the whole problem to you once more. So we found CD. So what we had to do was, the first thing is we had to use that property, the tangent to a circle is going to be perpendicular to the radius of another circle through the point. So from there, we started, just simple mathematics. So that property helped us establish that this is a right angle. So once this was a right angle, we could take the triangle and find the other sides. And once we found the other sides, take the smaller triangles involving the side that we had to find the length of. So CD was the side that we had to find the length of. So we had to consider the triangles ACP and all the things concerned with that. Now, apart from this problem being lengthy, as far as the concepts were concerned, it was pretty easy. We just had to assume that AP, let it be X, and then once you assume AP is X, we could find BP, and then we had to assume CP and PD had to be equal to Y, and then it was all simple steps. So this ends this problem and this video. I will see you in the forthcoming videos with more problems based on tangents to circles.